gradient vector and tangent plane when we are talking about plane, we are talking about also normal lines, so we can write normal lines as well, slash normal lines, like so. And what we're gonna put to use is the fact that the gradient is perpendicular to the tangent, and let's say that we're given the surface, f of xy. This is a surface level. F of xy z equals k at a certain point at x sub 0, y sub 0, z sub 0, then the tangent plane to the surface is given by, okay, so what will be the direction of the plane, the direction number of the plane? Well, the plane, remember from Monday, the plane is defined by a vector that is normal to the plane, okay? But by now we know that that will be the direction of the gradient. So we know that the direction of the plane will be the component of the gradient. So we're gonna write the following. If you recall, the equation of a plane is a times x minus x sub 0 plus b times y minus y sub 0 plus c times z minus z sub 0 equals 0, where a, b, c are the direction number of the plane. In other words, the vector component of the normal. Okay, in this case, those components will be the component of the gradient. So we're going to say that we'll have the following. We'll have del f del x times x minus x sub 0 plus del f del y times y minus y sub 0 plus del f del z times z minus z sub 0 equal 0, and that will be the equation of the plane. Okay. And this is just a comment. Recall that in general the equation of a plane is given by a times x minus x sub 0 plus b c z minus z sub 0 equals 0, where a, b, c are the directional numbers of the plane. Okay, the vector component of its normal. So in this case, the component of the gradient replaces the ABC. Okay, all right. Now what happens if we have equation two variables? Okay, when we have, so here this is a surface. If we are given a curve, In this case, it will be f of xy equals k, right? We need to tweak with it a little bit. And we're going to change that. We're going to say we let z equals f of xy, okay, and we're going to create another function, and we create a function f of x. Well, let me change it to uppercase f because it's not the same as this one. Could have used g as well, but let's do f of xyz equals f of xy minus z. Okay, like so. And of course this will equal to 0. And now we're gonna do this the same thing. We're gonna set up an equation of a plane like so. What is the gradient here? Del f, this one, the new one, of xyz. We take the derivative, then it will be del f, the derivative with respect to x. So it will be del f del x plus del f del y, and the derivative of big F with respect to z is simply -1. So you'll have del f del x in the I direction, del f del y in the j direction, and then -1 in the k direction. So we can write it as the vector component del f del x, del f del y, and then a -1, like so. And this is important, where the third component becomes -1 if you have a function of two variables only. So how the new plane going to look like? Okay, the tangent plane to f of x y equals k becomes, and we have the following, it will be, we're going to start with del f del x times x minus x sub 0 plus del f del y times y minus y sub 0. But what do we do here? Well, here we simply have del f del z is -1, right? So we'll stick that here as -1 times z minus z sub 0, and all of it equal to 0. So this is the modification. So this is for a tangent plane for two variable function, and this is a tangent plane for three variable functions. Notice the difference. So that's what happened when you miss a variable. So and you can see that if in case of a single variable we lose the z, and instead of del f del y times y minus y sub 0, we have what you learn in calculus 1. You'll have del f del x times x minus x 0. This is the slope times x minus x 0. And here you have plus y minus y sub 0 equal to 0. Or y equal y sub 0 plus the slope times x minus x sub 0. So what you see here is generalization of the point slope form. I don't know if you caught up with what I just said, but it's all the same thing. What we're learning as a single variable is now falling into place. And now I'm ready to give you an example